So observe very carefully here. The next chapter is laws of motion. So we're having more connectivity this chapter, which we already studied in class 9. So class 9, can anybody tell me what is the second chapter? Physics. All of you? Force and
Laws of motion.
laws of motion. So that is only in this force and laws of motion, 3 laws we studied. Do you all remember that? First, Newton's first law. Next, Newton's second law. And third one is Newton's third law. The same thing we are going to study again here, but here the mathematical things and strategies will change us. So laws of motion also we can call it as, what is this? Newton's laws of motion. Okay. So entire Newton's life from the birth time to death time. This is the most popular thing about the Newton's concepts and Newton's laws. It's a very popular one. So that is why laws of motion is the most important one, and as well as also this one we can call it as Newtonian mechanics. So which will discuss about Newton's laws. Okay. Now if you notice it very carefully, this Newton's laws, we are having many applications in our daily life. One of the best example you can see, olden days, or of course still today, if you go to temples and all, people used to get the water from the well with the help of a circular something, it is middle. What is that called as? Anybody can tell? So one side it will be rope, another side they will tie it and they will send the bucket into the well. So it will goes and fill the bucket. So that is only we used to call something here. The instrument, small instrument which we used to call as. Anybody's? What is to say? Pulleys. Everyone clear, Amma? So pulleys we used to call as. And same way we already studied the inclined surfaces. When the object is moving in this inclined surface. Do you all remember this one? How the weight will act? What is the direction? X direction, Y direction, everything? All of you? Udreswa? So like this, when the objects are sliding in the inclined surfaces, as well as when you are using the applications of pulleys, everywhere we'll get this laws of motion. That is what Newton's laws of motion. Now, let us start with this. So if you notice it, last 2 chapters, what is the things we discussed? Anyone can tell? Just at least chapters names. Motion in 1 dimension, and the second chapter is motion in 1 dimension. And what is the third chapter, everyone? Motion in 2 dimensions. That is what we can say. Motion in straight line and as well as motion in a plane. These are the things we discussed. Am I right, everybody? Yes. So if you notice it here, that is why I choose the name of the chapters. Can you remember, or when we are writing the second chapter and third chapter, we have kept the heading. What is the heading we kept, everybody? We used to call it as kinematics. So in this entire kinematics, we discussed the effect of something, like due to the effect of something, what changes will take place in the body. Either the body is said to be in rest or the body is said to be in motion. That is what whole story about the kinematics, what we studied in last 2 chapters. Am I right or wrong? So we are saying what way the body is moving, either the body is moving or not, with respect to something, the body is said to be in motion, or with respect to body is said to be in rest. That is what will deals about kinematics, which we studied motion in a plane and as well as motion in a straight line. But now, who makes the body to be rest? Who makes the body to be motion? That is what we used to call. Who is the cause behind it? And who is causing this effect? Cause and effect we are going to discuss in this chapter. That is what Newton's laws of motion, which we are discussing about the cause of position of the body, either it is a state of rest or state of motion. That is the separate branch of physics, which we used to call as dynamics. Clear, everybody? Kinematics will deal about the state of body, like the body is in rest, or body is in motion, or body is in uniform motion, or body is in non-uniform motion, or body is in constant velocity or uniform velocity, some XYZ. That is what kinematics. Dynamics will deals who is making the body to be in state of rest, what is the effect of body, why it is in a state of rest, what makes the body to motion, how the body is in uniform motion, how the body is said to be in uniform acceleration, who is making, that is what we used to call as cause. That is only we are going to study. That is what we used to call, everybody, we used to call as, yes please,
Dynamics.
dynamics. Clear? So for example, let me take, this is the surface. Mr. Prados, can you able to catch my point, what I'm saying? So for example, let me take now,
Yes, sir.
Mr. Sai Karthik is present here. Let me, he is, just imagine that he has been packed in a box. Just little I'm taking, or else you consider a small box. Now box is started with some initial velocity u, and finally it has been reaches to the certain point who is having a velocity v. Now this is only we used to call in physics change in state. That is what state changes from this point to this point. Am I right or wrong? The position of the body changes from one point to another point. Am I right, everybody? Yes, please. So who is causing to change the state? Change the state means, don't remember liquid to gas, gas to that. Position. The state of this body is moves from point A to point B. Who is causing this? How the box will move? Something should be applied. What is that should be applied, everybody?
Force. Force.
That is only called as cause. That cause, the cause behind the state of motion or state of rest, whatever it is. What is behind, everybody? All of you.
Force.
Yes, force. That is only the laws of motion. We are going to discuss entire laws of motion chapter. What is force? How it makes the body to move? What kind of effect of force and all? I think from class 8th, class 9th, everywhere you studied what is force and what is effect of force and all. Am I right, everybody? Yes, please. Of course, you remember or not, I don't know, but that's fine. We don't have any importance of that. So let us comes to the units of force. Can anybody remember what is the units of force? Everybody fastly.
Newton.
Newton. So which will represent with the N. So actually this is the SI unit. What do you mean by SI? Anybody? This is what is our life. That is why even Prados, for you 1000 times I told you. What do you mean by SI units? At least CGS and SI units full form you have to know. What do you mean by SI? Any one of you? Standard international. Yeah. Means in the sense of internationally accepted units. With these units, you can survive anywhere in this country, anywhere in this world. That is what SI unit. So for every physical quantity, you must have to know the SI unit. And if it comes to the CGS unit, what do you mean by CGS? Anybody? From 8th class, I taught even for Manya.
Centimeter, gram, second.
Centimeter, yeah, centimeter, gram, second units. So this is what is our Indian system of units. So the CGS unit of Indian system of units, for every physical quantity, you must know this SI unit and as well as the CGS unit. It's necessary throughout our education. It will be. So the CGS unit of force, anybody can tell what is the CGS unit of force?
Dyne.
Okay. So that is what 1 Newton is equals to 10 power 5 dynes. Please listen. How many dynes, everybody? 10 power 5 dynes. So you all know already we studied last chapter also. Force is equals to mass into acceleration. As it acceleration is a vector quantity, and as well knows force is also a what quantity? Everybody. Yes.
Vector quantity.
Force is also a vector quantity. Do you all understand what I am saying? I want to know the response. Clear, everybody?
Yes, sir.
Yes. So now we are having these types of forces, many types of forces you might be studying in 8th class. At least any 2 4 types of forces which you all remember. Anybody tell me? Basically, forces are divided 2 types in class 8. Any one of you? Contact forces and as well as opposite non-contact forces. Do you remember? So that is what is our next concept. Types of what? Everybody. Types of forces. Okay. Having totally 4 types of forces, different varieties. Of course, class 8 will study only 2. One is non-contact forces and second one is what, guys? All of you. Contact forces. Third one is actually, even first chapter I used to tell you, what is the weakest forces? For those remembered? Weakest force. Gravitational forces. Okay. So third one is weak forces. Last one is nuclear forces. Okay. So anyhow, nuclear forces we will study in class 12. So we don't have any touch here. And weak forces, one of the example, actually we will study the weak forces in chemistry. One of the example is Van der Waals equation. So Van der Waals forces. So these are the examples of Van der Waals forces. These are the examples of weak forces. Of course, this also will study in chemistry. So we do not have any importance here. Now, contact forces. Yesterday also I studied, I taught you. If a boy is revolving a stone in a particular path, something is acting in the string. What is that called as? Anybody? The force exerted by the string, we used to call as? What is to call?
Tension.
Tension. Do you all remember, everybody? So the accelerating force is act along the center of the, or towards the center, or we can say what? Along the what? The centripetal force is acting towards the center, or it is acting along the
Radius.
radius. So contact forces, if you have taken, they are having multiple contact forces. The first one is tension. So which is acting in a rope or a string, whatever you have. Next, last class only I taught you. Do you all remember that normal reaction, everybody? All of you? That is what normal force will say. Normal force always how it will be acting. Suppose if the weight of the body is acting downwards, weight is equals to mass into acceleration due to gravity. Then normal force will act what direction? Everybody. What direction? Perpendicular to that. That is what is the angle, everybody? How much is the angle? 90 degrees. So that is the force we used to call as normal reactions or normal forces. Next, you might be all experience the spring forces. Of course, we'll study that also. So spring forces, which is what we used to call either Fs or we can represent with the Fsp. Spring forces, or we can say Fsp. And same way, the main contact force. What is the force? I have written already 4 letters. Anybody?
Friction.
Friction. So these are the 4 different types of contact forces. Now, non-contact forces means you are all familiar. At least one from your mouth. Anybody? First, the familiar force is, what is
Gravitation.
Gravitational force. Clear? Now, entire class 10th, sorry, class 11th, we are going to study what? Only one force, one non-contact force. What is that, everyone? Gravitational force. Second one is electrostatic force, and the third one is magnetic force. These two we will discuss in class 12, and class 11th we are going to study only one. What is that force, everybody?
Gravitation.
Force. Do you all remember? I think you might be understand. Class 9th, by the time, your time, chapter number 11 is the gravitation chapter. Am I right, everyone? 9th class? Yes. All of you remember the gravitation chapter? Please respond. Class
Sir,
9.
10.
Yeah, chapter number 10, I think. Am I correct, Rudreswa? Yeah, chapter number 10. 8, 9, 10. Correct. So gravitational force, even class 11th, verify the chapter number 6 in our textbooks. I think you have a chapter number 6. What is the chapter number 6? Check it and tell me. What is the chapter number 6? All of you.
Chapter 7 only gravitation.
Yeah, okay. I think old book it is a chapter 7. Oh, sorry, chapter 8 it is. So, okay, now it's the chapter 7. Do you have a new book or old book, Amma?
New ones. New books.
Yeah, new one. So, it is the last chapter, I think. So, last chapter is your gravitation chapter, which entirely speaks about the gravitational force alone. So, we're having whole chapter regarding that. What we studied in 9th, like Kepler's laws and all, it will continue. So, class 11th only will stress on gravitational forces. Remaining contact forces, we do not have anything. So, and weak forces, what is the examples of weak forces, everybody? Weak forces, Van der Waals forces, which we'll study in chemistry. Of course, 11th and 12th chemistry will study it. We're having equations also for this. And nuclear forces will study only in class 12th. Now, two forces you should remember, that is what? The force which is acting downwards and as well as the force which is perpendicularly to the downward direction. What is the force we used to call, everybody? We used to call as normal reaction or force. Okay, so let us see that. Now, all of you observe last class, one of the example we remember we solved best like big question, calculating the tension in the string. Do you all remember, everybody? Tension in the string, 1 kg ball, next 2 kg mass and 3 kg mass is attached. Do you all remember, everybody? Tension
Yes,
is
sir.
always act away from the body. Remember, Dreshwa? This is
Yes.
one iron pole is it attached and revolving. It is moving with the same angular velocity. Do you all remember this, everybody? Then they ask us to find the tension in these strings, each strings individually. Am I right or wrong? Everybody respond, guys.
Yes, sir.
Yes, that is.
Sir.
So observe very carefully. Always tension act in the away from the mass. And you remember, if the string is same, then always string is same. That is what? Then the T also same. So if the string is not going to change, see from here to here string is changing, from here to here string is changing. If the string is not going to change, then T is always remains what? Everybody, all of you. Time period.
Same.
Yeah, T, if you observe very carefully, time period not. T means what, everybody? It is tension in the string is always remains constant. Be very careful. Okay. Now let us take how to mention the these tensions and as well as the normal forces which is acting on the body. So let us consider one triangle now. So there is no right angle triangle. Yes, of course. Very good. So we all knows that it is an inclined surface. All of you observe very carefully. What is this actually? It is the, all of you, inclined surface. Let me take now one rigid object, rigid hanger is there here. So one block is attached to this rigid one. Okay. So on this one. So let us draw neatly. See how to measure it. Be very careful. One, you understand. Two, you understand. Very easy to make it. So I'm keeping between this to this one. I'm putting a block. Okay. So now observe very carefully. I will explain one or two, then you proceed it. So the block present between them is this one. This is the block I have. Now observe here. Actually, this is called as wedge. What is to call this inclined surfaces? We used to call as, everybody, wedge. Okay. Like you can see wedge in the sense of for cars and all down. When the car is in a down angle, the wheel should not move forward. So we'll fix something. Do you notice it? Lorries and all, they'll put it, everybody.
Yes, sir.
All of you?
Yes, sir.
Yeah, that is only like wedge. You just remember. So it is a wedge which will represent with a W. Clear? Now, we all knows that if the gravitational force, of course, if you consider this point, gravitational force always act what direction? Everybody, we all knows that. So let me consider
Downward.
this surface, downward direction. So let me consider this is a surface, that is also very important. So always you remember, wherever the surfaces are contact each other, definitely they are exerting the forces. That is what you all should remember. So I'm taking this is as a what, everybody? Surface, ground, clear? So now if you notice it, here, all of you observe very carefully. The normal force which is exerted by wedge on the surface, always it will act what direction? Perpendicular. Keep it in mind, perpendicular means what direction it will act, all of you? Yes, please. N, let me take N, normal force. Okay. Now, the block is going to touch this wedge here. Now you observe very carefully. The perpendicular force which is acting to this, that is what we used to call as, let me take normal, N1, normal force. Clear, everybody? Now, the wedge is exerting this normal on this block. So that block also will exert force on the normal, sorry, this wedge. That force will act exactly perpendicularly opposite to this first N1. Same way, the wedge is exerting force on surface. Let me take it now as a N2. Then the surface also will exert a normal force on the wedge. That is what we used to call as N2. Do you understand, Rudreswar, what I'm saying? Clear? Now, this is a block. B means block. Now, the block is exerting force on the surface. Block is exerting force on the surface. Sorry, the surface, this rigid surface is exerting force on the block. So that is what, let me consider as N3, normal force. Then the block also will exert force on this rigid surface. That is what also we used to call as what, everybody, which is also we used to call as, please respond. Normal. Clear? So normal force. So always one surface is exerting force on the second surface. The second surface also will exert the force on the first surface. Hope you all understand what I'm saying. Pradosh, Rudreswa, how to find the normal force. Okay. So let us consider for example. So we all knows that I put a one statement. String is same, tension is what? Everybody. If the string is same, tension is what? T is, please respond. T is same. Clear?
Same.
So let us understand one rigid hanger is there. So for that, I am tying a mass of M1. What I am tying, everybody? Mass of M1 with some string or rope or whatever it is. For that, with another, I attached a body M2. Now this M2 is attached to the another rigid surface. Now, first body is exerting tension. So now you tell me the tension always moves, I all told it. Tension always moves towards the body or away from the body? Everybody. It will move away from the body. So the body, let me consider the moving away from the bodies. Let me consider this is T1. Then means the tension exerted, that is what to hold this M1 by this one is T1. So as it will act always, that is what. Then the tension exerted by this one on this M1 also will become what? Same string, same tension. That is also will become what? Everybody. Same string,
T1.
same string,
T1.
same tension. Then here, if you notice it very carefully, the tension which is exerted again moving away, it will become what? Moving towards to this one. It will become what? Everybody. All of you, T2. Then the tension, because string changes, so tension will change or not? That is what my question, everybody. String changes.
Yes, sir.
So tension will change. Let me consider that is T2. Then here also it will move away from the body. Then this is also string changes. That is also how much it is, everybody?
T2.
T2. Do you all remember that question which we solved, everybody? Same
Yes,
thing.
sir.
Next, the tension exerted by body M2, that is what towards to this rigid surface. What it will be, everybody? That is will become, I will assume and say T3. And this rigid surface will exert on this. That is also we used to called as what? Everybody? T3.
T3.
Yeah. So that is how you need to calculate the tensions. Of course, we'll solve many sums in this. You should understand the concept. That is what I'm saying. Do you all understand what I'm saying, everybody? Yes?
Yes, sir.
Now, observe very carefully. If your body is hanging here, let me consider now M1 is hanging here. Now we all knows that always some force is acting downwards. What is that force, everybody? Which is equals to what? Weight. That is only we used to call as mass into Acceleration due to
Acceleration
gravity.
due to
You should
gravity.
speak. Unless you are, you cannot. So weight is always acting downward. So perpendicular to weight, always something is acting. Just also now also we have drawn in the first picture. What is only
Normal
called as normal force. So like this, if I have taken a bulk object, it is very difficult to find all the types of forces which is exerting. So let us consider for any kind of diagram they have given in the physics. Keep in mind, always I will say in class 9th also, class 10th also, draw the diagram. A diagram will make you clear about what is your target and what you have to get it. So that is only ways to called as F, B, and D. Can anybody guess what do you mean by F, D, F, B, D? Any one of you? Tiger, please check it. What is the speaker problem? FBD means we used to called as free body. Everybody. Free body diagrams. That is what we used to called as FBD. For any kind of question, whatever the systems they are giving, whatever it is considered, the step 1 is the meaning of free body diagram is they will give the big bodies, big mass, very large size and all. Whatever the body, you must always consider as a what mass? Everybody, it must be considered as a
Point mass.
point mass. That is the first assumption must be made by you all people. So whatever the body is considered, if you want to solve, you have to consider whole mass of the body as a what mass? You have to consider whole mass of the body as a point mass. Yeah, that is what. Next, in that point, for example, mass of the body is 5 kg. Consider this mass as a dot point. Then, second point, we will show all the forces acting on it, acting by it not. Understand what is the difference between acting by it or acting on it? Aswita, Manya and Samya. So we have to list we will show all the forces acting on it or acting by it, everybody. Acting on it. So what are the forces are experienced by this body? We all should identify it. That is the second thing. Next, third one, forces. What kind of forces are exerting? And keep it in mind. For example, if you all notice it, if I am standing on the earth along with my friend, I will appear to be always in state of motion or state of rest. Everybody, if A is observing me, now both are in the same position. I will observe. With respect to A, B is in state of rest, and with respect to B, A is also in state of what? Everybody, rest only. Okay. Class 9th concept, motion, and as well as state of rest. Do you all remember, everybody? Yes, please. Motion means with respect to surroundings, if the position is changing, suppose the body is here, after 1 second here, after 1 second here, after 1 second here. So like that, the body position is keep on changing. Then that body is said to be what, guys? That body is said to be what, everybody? At least basic thing. That is why I said you to revise the 9th physics. So if the body is continuously changing its position, we used to call it as body is said to be in what, everybody?
Motion.
Body is said to be in motion. If with respect to time, there is no change in position of the body, then we will consider body is said to be in what, everybody? Yes, rest. Same way, if you notice it, if I am seeing my friend from the same surface, my friend appears to be stationary, is not appears to be moving. But now I will go to the space. Now, if I am seeing my friend, now you tell me, my friend appears to be motion or my friend appears to be stationary. Anybody?
Motion.
Motion. Because as we all know that earth is keep on revolving. As earth moves, before what happened? We both are in same surface. That is why with respect to me, he is in state of rest. And with respect to you, my friend is also. Like with respect to me, my friend is in state of rest. With respect to my friend, I am also in state of rest. Because both are lying in the same surface. But as soon as if I jump into the space, then if I see my friend, My friend appears to be moving, but actually he is in stationary. Who is moving there by the time? Everybody? Yes, please respond, all of you. Who is moving? Earth is moving. So because of Earth is moving, this man also appears to be moving. So that is only, see, both the cases I am only observing my friend. But one case my friend appears to be in motion, and another case my friend appears to be in rest. This is only called as observer, or we will say forces acting. So across the frame of reference. That is very, very important. Always I will speak about this. So reference frame, that is what? Observer. So based upon the observer's view, the same object may appears to be in motion, or the same object appears to be in what, guys? State of rest. That is what. So with this observer reference point, we all can calculate number of forces acting. Understanding? Number of forces acting completely depends on somebody. Who is that? Everybody? Depends on observer. Do you all understanding? If I see the same object from the earth, I may feel it may experience different forces. Same object I will take it to the space. There I may be feel my body is experience different other kind of forces. Am I right or wrong, everybody? Please respond it. Yes? So because place to place, position to position, the types of forces acting may varies. That is the reason. So mostly that is the reason, if you notice it, observer, majority of the cases, 99%, observer is taken from the ground. Observer from where, guys? Observer from ground. Means, I mean, remember before we have solved some questions like one boy is standing outside and one boy is, like you can see one boy, this is ground. The boy who is observing us from the ground is your what? Is your, everybody?
Observer.
Is your observer. So according to the observer point of view, the types of forces acting on your body will change. So these are the 3 steps which you all need to remember to make a free body diagram. I will explain you now how to draw. Free body, what it is? Free body diagram. There is no physics without free body diagram. If you are good at, how much you are good will speak, your free body diagrams will speak what you are depth in physics mainly. So as I told you, for example, we all consider like how to convert it. So how many rules for free body diagram? Everybody, very simple rules it is. How many rules it is? 3 rules. Am I right or wrong? First rule, let me take with an example. I'm having a surface. What is this, everybody? I'm having a surface. We all knows that. Now, I have been placed some object here whose mass is m. Whose mass is how much, Amma? All of you? M. Now, as we all know that the mass is directly contacting to the surface, so that I can say the force which is acting, suppose, let me consider this entire body as a point object. That is what is our first target. Am I right, everyone? You should speak, I cannot. All of you, sir?
Yes, sir.
Yes. Now, as we all know that any object is kept on the surface, some force is acting downwards. That is what on the ground. We used to call it as what? All of you? mg. mg is only called as what? Newton's second law. Am I right or wrong? Everybody, weight or work, weight, or we can say another work, what? Yeah, force or weight, both are same formula. What is the unit of force and weight? Both, everybody, force is equals to mass into acceleration, weight is equals to mass into acceleration due to, you should say before,
Gravity.
acceleration due to gravity. Clear? That is what. So I chosen a point m, like see, entire body I have chosen as a point m. Then if the weight of the body is acting downwards, opposite to that is what? Mg, not Wg. W is equals to mg.